Hey guys, we are now continuing on to page 2 of our algebra review. And so on number 18, we need to evaluate this expression. So the first thing I'm going to do is some distributing. So I'm going to do 3 times x and 3 times 5. So I've got 3x plus 15 plus 22 minus 2x minus 18. And then I need to distribute a positive 3/5. 3/5 times 5 is 15/5, which is 3. So I've got plus 3x. And then 3/5 times 10 is going to be 6, but that's a minus 10, so minus 6. Okay, so that 3/5 times 10 is like 3/5 times 10 over 1. That's 30 over 5, which is 6. Okay, next I need to combine some like terms. I have a 3x minus 2x plus 3x. So 3x minus 2x is 1x, plus 3x is 4x. Okay, then I've got 15 plus 22 minus 18 minus 6. So 15 plus 22, that's 37. 37 minus 18 is 19. And 19 minus 6 is 13, so plus 13. Okay, number 19. 3 times 5x times 2x over 3 times x cubed. So all of these can be written as fractions over 1. And I see that I can cancel out these 3's, so those are just gone. Those turn into 1's. So I've got 5x times 2x, that's 10x squared, times x cubed. So 5 times 2 is 10. X times x is x squared times x cubed. We just add all of these exponents. 1 and 1 and 3 makes 5. So 10x to the 5th. Now notice that there are x's for our multiplication symbols. There are also x's for variables. I put that in there to point out that we really need to move away from using x's for multiplication when we're using variables especially. When we're going to use variables, these multiplication symbols look like x's. Even if the variables are y's or z's, these x's can be multiplied or can be used as multiplication or confused as a variable. So please don't use x's. Use the dots for your multiplication. Okay, now solving some equations. 4 minus 3x equals 13. We're going to subtract 4 from both sides. At this pre-calculus level, we don't have to show every little minus 4 and all that kind of stuff. We're just going to do the subtraction. Minus 3x or negative 3x equals, and then 13 minus 4 is 9. We don't really need to show the division that we're going to do either. We just need to write the next step. X equals 9 divided by negative 3 is negative 3. Okay, number 21, we're going to subtract 4 again. So negative 3/4 x equals 13 minus 4 is 9. Okay, then I am going to multiply by the reciprocal. So that's times negative 4/3, and that's gone. Okay, so x equals, I can simplify this 9 and the 3, so this is really 9 over 1. So the 9 and the 3 simplify to 3 over 1. So I've really got just 3 times negative 4, and that is negative 12. Number 22, let's move that 4 to the other side. 3x equals 12 minus 4 is 8. And divide, x equals 8 over 3, and we're going to leave it just like that as an improper fraction. Number 23, I have an exponent here, but before I can do exponents, I've got to do this multiplication here. When you're solving an equation, it's inverse order of operations. The exponent goes last here, so I need to divide by 3. X squared equals 12 divided by 3 is 4. And then when I take a square root, anytime I take a square root, I automatically get two answers when I'm solving an equation, plus or minus, and the square root of 4 is 2. The reason for that is that if I plug this back in here, positive 2 squared is 4, negative 2 squared is also 4. Whatever the biggest power is, that's the number of solutions you need. So just understand that when you have a power of 2, you're going to get 2 solutions. Number 24, I need to divide by 3. The square root of x equals 12 divided by 3 is 4. And this time I need to square both sides in order to get that square root out of there. So I get x equals 16. Now, anytime you solve an equation with a square root in it with a variable under that radical, there is the possibility of an extraneous solution, which means that we do all the work correctly, but we plug that answer back in and it doesn't work out right, which would mean that this solution is not valid and we would have no solution. So let's go ahead and plug that in. 3 times the square root of 16 equals 12. The square root of 16 is 4, so that's 3 times 4 equals 12. 3 times 4 is 12. That is true, so that answer is valid. Okay. Next one, I see that both terms here have an x. I can factor that greatest common factor of x out, so I get x times, and then when I divide both of these by x, I get x squared minus 9 equals 0. Okay, now I can factor this right here. Okay, I can factor that as a trinomial if I put in a 0x term, or I can recognize that this right here is called a difference of squares. It's called a difference of squares because they're both square numbers. X squared, its square root is x. 9 has a square root of 3, and there's a subtraction, which is also called a difference. It's the same as x squared plus 0x minus 9. If we want to factor that, we're looking for two numbers that multiply to negative 9 and add to 0. Those numbers are 3 and negative 3. Anytime you're factoring a difference of squares, you can go straight to, and I'll put that x there first, the square roots, one with a plus, one with a minus. X plus 3 times x minus 3. Okay, now from there I get three different solutions. If these are going to multiply to 0, then one of these three factors at least has to equal 0. So x is 0, x plus 3 is 0, x minus 3 is 0. So that gives me a solution set of x equals 0, negative 3, and positive 3. Number 26. First, let's move this to the left side. And I'm going to have x cubed minus 4x squared minus 21x equals 0. I see that all three terms on this side have an x in them, so I'm going to factor that out. X times, and then I'll divide all three terms by x. X squared minus 4x minus 21 equals 0. Now, what two numbers multiply to make negative 21 and add up to negative 4? I think those numbers are going to be negative 7 and positive 3. Negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. So I still have my x in front, and then I have x minus 7 times x plus 3 equals 0. Now, in the previous problem, we split that into three equations and wrote our answers. Let's just go right to our answers here. X equals 0. What value of x makes this equal 0? 7. What value of x makes this equal 0? Negative 3. Number 27. First, I want to move this 5 to the other side, so I'm going to add it. 7x times the square root of 3 equals 5. Now I want x by itself, so I'm going to divide by 7 and by the square root of 3. Okay, now there's a rule in math that we do not leave irrational numbers in the denominator, so we need to rationalize this denominator. So I'll multiply top and bottom both by the square root of 3. So the top is 5 times the square root of 3. The bottom is 7 times the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. So I really have 7 times 3 here. The denominator is 21. And number 28, last one for this page, the square root of x plus 8 equals positive 5. So I just move that to the other side, change its sign. Now square both sides to make that square root disappear. X plus 8 equals 25. And subtract 8, x equals 17. Now once again, we've got a variable under a square root. I need to check and make sure that's not an extraneous solution. 17 plus 8 square root minus 5 equals 0. So we're plugged back into the original. 17 plus 8 is 25. So square root of 25 minus 5 is 0. Square root of 25 is 5. 5 minus 5 is 0. And I know that's true, so I know that is a valid solution. And that is the end of page 2.